Now a spring combination, a spring combination, a spring combination, a spring combination means there will be two or more spring. Combination of a spring balance machine. First, first, first will be our series combination. Series combination. In that case, how to solve this kind of a question? Let me write first of all. First of all, this is our figure. Okay, this is our figure. First a spring, which is like this. First a spring. One object in force is in this direction. Acting force is forward. This is our K2, K1, a spring constant. A spring constant 2. If you figure question is just something like that, then how would you like to solve? Just observe. Is a combination in series mode? Combination is series. Yeah, this is a series combination. Series combination. Just understand your x will be x1 plus x2. Your x will be x1 plus x2 means k1 plus k2. Just add, okay, just add, nothing else. And your f1 will be equal to f2. This f1 will be equal to f2. Whatever will be force over here will be also equal to 2. Okay, so f1 will be equal to k1 x1. Okay, k1 x1. On the first spring, our force will be k1 into x1. Okay, on the second spring, our force will be k2 into x2. K2 into x2. So you can say k1 x1 is equal to k2 x2. If force on this spring is 15 Newton, so force on K2 will be also 15 Newton. Am I correct? Am I correct? Yeah. You can write from here. You can write from here. F will be F upon K will be equal to F upon K1 plus F upon K2. If a combination of a spring balance are in series, then just divide all the forces by constant spring and then add F upon K1 F upon K1 plus F upon K2. Here we are saying total force by total spring constant. Okay, this formula, or you can say this equation, we will use when a spring are in series. Okay, a spring are in series, then just our F upon K will be equal to F upon K1 plus F upon K2. This equation. So remember, x1 is equal to F1 upon K1. Remember, x1 is equal to F1 upon K1. Can you write F1 is equal to K1 into x1? Yeah. So from the basic spring force, this came over here. Finally, you can write 1 upon, if force is 1, then you can say 1 EQ is equal to 1 upon K1 plus 1 upon K2. This equation we will use. Okay, when it comes to parallel combination, parallel combination, combination. Figure will be something like that. One string, K, another string, K1, K2, K1, K2. If a string violins are in parallel, then our formula would be F will be equal to F1 plus F2. Okay, F1 will be equal to F1 plus F2. That means x1 is equal to x2, k1 is equal to k2. Okay, so over here your total k equal will be equal to k equal into x will be equal to total force k1x plus k2x, and k equal will be your x will be common, x will cut to each other, so k1 plus k2, that is how this equation came. Okay, that is how this equation came. Over here f was common, clear? So f1 will cut to each other. Now in this case x is common, so k equal total aspirant constant is equal to k1 plus k2, just aspirant constant. Now next concept. See over here, f upon k, not k equal is equal to what? X1. So same over here, x2 is equal to x, total x is equal to x, x1 plus x2, x3. Over here f1 is equal to f is equal to f1 plus f2. Okay, so f is how much? K equal multiple x, and this is value of f1, this is value of f2. Here we are trying to understand total force, how much total force is being pulled by the spring. Total force we are finding, and over here we will divide the force. Okay, we will divide force. So 5 Newton will be over here, 5 Newton will be over here. Over here we will get total, and over here this will get 5, this will get 5. Next, cutting of a spring. Cutting of a spring. Cutting of a spring. Initially, length of a spring, constant of spring was this length. This is a total length. This is total length of the spring. Total length is L. If you cut the spring half, this half, then what will be length of the spring which we cut? So answer would be L upon 2. Answer would be L upon 2. Just this half part of the complete spring. L upon 2. Length will be L upon 2. Simple. So remember, over here K is inversely proportional to a length. If K is increasing, then L will decrease. If L is increasing, then K will decrease. Okay. So over here, our K increased. K increased. Spring constant. K will increase. And over here, K will decrease. So KL multi product of KL will be constant. Remember. K1 L1 is equal to K2 L2. Whatever will be value of K1 L1 will be equal to K2 L2. L is a length, K is a spring constant. Okay, K is a spring constant. Let's use this concept in our question. Question is, if a spring is cut by L by 3 distance, then find out a relation between K1 and K2. Figure is something like this. A spring. This is K, a spring constant. Length is L. There are 3 parts. Okay. There are 3 parts of a spring. If a spring is cut by L by 3 parts distance, then find out the relation between K1 and K2. A relation between them. So remember, you know KL is equal to K1 upon L upon 3. You know. So over here, your KL will be equal to K2 left part will be your 2L. Am I correct? 2 by L you can say 2L upon 3. So your second constant spring will be 2L upon 3. Second part we took. And third part, K1 will be equal to 3K1. And K2 will be equal to 3K upon 2. L will cut to each other and 2. So 3 will go upward, 3K upon 2. So K2 is 3K upon 2. Means 3 times constant and just divide by 2. And over here K1 is equal to 3K. How? K L will cut to each other. So K and this K1. So 3K. 3 times constant. So for this over here we have 3 times constant. For second cutting a string, we have 3K. 3 times, just divide by 2. Okay, just divide by 2. 3K divide 3K by 2. Will be your K2. Will be your K2. Now try to understand meaning of try to understand meaning of pseudo force. Pseudo force. Do you know meaning of a pseudo force? Yeah, it is different from the previous force. Yeah, it is a different, but not difficult. Before we understand pseudo force, let's explore some basic words. First is frame of reference. We can take any reference, any frame, which will be object. According to that frame of reference, we are going to see what another object is moving or is in a rest. So it will be decided by the frame of reference. Frame of reference. So yes, it is a compulsory to take a reference. Okay, to take a reference so that location or state of any object can be described by that reference point. Okay. Second, we have inertial inertial frame of reference of reference. Inertial frame of reference. Try to understand with 100% concentration. Just inertial word we added over with frame of reference. With frame of reference. Meaning is definition would be what? It is saying the frame for which law of inertia is applicable. Inertia means here whatever we study about inertia of rest, inertia of motion, inertia of direction will be applicable for this frame of reference. Whatever we will take frame of reference, so that frame of reference will follow the laws of inertia. Okay, the frame for which law of inertia is applicable is known as inertial frame of reference. Again, I am telling you, there is an object which is following law of inertia. Law of inertia. For example, the object is in rest. That object will be in rest until and unless external force will be applied. Yeah, if object is moving in with a constant velocity, that object will be moving with constant velocity all the time until and unless external force will come into picture. Okay, this is enough. Inertia laws are being followed by the frame of reference. Right? For example, there is a person inside a truck. Okay, and the truck vehicle is moving with a constant velocity. So your answer would be yes, that object will be moving with a constant velocity. Yeah, that object will be moving with a constant velocity. All the frames which are at rest or moving uniformly with respect to an inertial frame are inertial frame. Inertial frame. If object is moving with the velocity, then that will be our inertial frame of reference. Inertial frame of reference. Next, opposite of it is a non-inertial frame of reference. Just definition would be opposite. So, how to define? Just say, uh, the laws of inertia are not being followed by frame of reference is our non-inertial frame of reference. Means frame of reference point is not following laws of inertia is our non-inertial frame of reference. I hope we have understood. Okay, we have understood. All the frames which are accelerating or rotating with respect to an inertial frame will be non-inertial frame. Okay. Object is accelerating, object will be rotating according to inertial, but will be non-inertial frame. We will say there is a truck who is moving. There is a truck who is moving on the road. Inside this truck vehicle, there is a person. There is a person who is at rest. Your answer would be the velocity of a person is zero according to truck, according to vehicle. But according to the second person who is standing on the road, then velocity will not be equal to zero. Now inside this truck there is a what? Object. There is an object. This pendulum is rotating. According to person A, you would say the pendulum is in motion. According to person. But over here, it is saying this will be our non-inertial frame. The reason is object is accelerating. This object is not moving with a velocity, with a constant velocity. This is main reason to say that inertial frame of reference is a non-inertial frame of reference. Main reason is object is accelerating with respect to frame of reference. Okay, if object is accelerating with the frame of reference, then you say that yes, our inertial frame is a non-inertial frame. Okay. So over here, acceleration will not be equal to 0. Now let's come to the main concept, which is pseudo force. This is the last concept, pseudo force. Remember, it is not actual force. Okay, this is not actual force, but apparent force. You will not get actual force. So it is a apparent force which is used to explain the motion of object in a non-inertial reference frame. In short, you would say the laws of motions of Newton will be invalid for pseudo force. Okay, so that's why to follow laws of motion of Newton, we will have to use pseudo force. Okay, pseudo force. Second point is this force always works in the direction opposite to that of acceleration of a frame, and it is equal to product of mass of the body and the acceleration of another, or you can say non-inertial reference frame. Did you understand? Long and short formula for pseudo force will be equal to mass of the object, mass of the body, and acceleration of the reference object, or you can say non-inertial object. So reference over is a vehicle, but inside the vehicle is our man. Here mass of the man will be taken for this formula. So pseudo force is equal to minus m, and minus sign is for negative direction. Clear? Negative direction. Let's apply this formula, this equation, pseudo force on coming equation. First question is there is a triangle. Clear? Rectangle, block M, theta, inclined. Question is asking to you, find out the normal reaction. Okay, normal reaction between block, this block and wedge, this wedge. Normal reaction. I think this would be normal reaction. And horizontal acceleration. It is talking about this horizontal acceleration, not vertical. Okay, of wedge, for which block remains at rest. Block should not be moved. Okay, so what would be acceleration with respect to wedge? Block is rest with respect to wedge. Okay, we know that block is rest with respect to wedge. Means you can say, if a block is in rest, next external force is 0. Net force will be 0. Am I correct? Now, normal force is in this direction. Normal force will be upward. This is our resultant of N. So normal force is like this. This is our normal force. So perpendicular, this perpendicular will be, these are two components of a normal reaction. This N. If you are taking this theta, so according to this theta, this will be your n cos theta, n sin theta. Here, mg will be downward, which is mg, and in this direction will be your ma. So component of MA according to this theta, will be your MA cos theta. Now you can write A is equal to, you can write mg sin theta is equal to ma cos theta. This ma cos theta is equal to mg sin theta. This is one component of the mc. So another will be component of m will be our over here ma sin theta, and upward will be ma cos theta. mg sin theta A is equal to, in this direction, A is equal to G tan. This is your word. I am going to take a direct question. Direct question. Direct question. Direct question. There is a ball which is attached by this string, by this string. So acceleration is in this direction. Acceleration is left in this direction. Let's solve. Question is a ball of mass m is hanged from ceiling of horizontally accelerated curve, then in equilibrium. Find out tension in string or angle made by string from vertical. This is our question. There is a vehicle. Here this bomb is attached by a threshold from ceiling of a horizontally accelerated car. Okay, then in equilibrium, find out the tension in this string. What would be tension in the string or angle made by a string from vertical? I think it is asking this. From vertical. So how to solve? Mass of the bomb is not provided. Look at it. This is a bomb which is attached from ceiling. So tension will go there. Tension will be in this direction, which will be our T. And there is a theta, this is our theta. So in this direction, our will be total force which will be equal to M. Okay, M A, and downward will be MC. And in this direction, according to this theta, this will be our T cos theta, and this will be our T sin theta. This is one component of a tension. This is another component of a tension. From here you can easily write that T sin theta is equal to M, T cos theta is equal to mc. So T sin theta is equal to ma, and T cos theta is equal to mc. Am I correct? From this two equations, you will get sin theta upon cos theta, which will be equal to M will cut to each other, T will cut to each other. So tan theta will be your A upon Z. A upon Z. So to calculate the theta, this will be equation will be tan inverse on A upon Z. So T sin theta was your MA. Just put the value of theta. Just put the value of theta. This will be your answer. To keep remember important points that we have are what? Pseudo force will not follow the action reaction law, which is a law of motion of Newton. Third law of motion will not be followed by the pseudo force. Reason is this is not actual force, okay, but apparent force. That's why actual reaction law will not be valid for pseudo force. Level of liquid in container. First of all, let's draw level of liquid. This is the, just see in this direction, this will be T. Just break the component of a resultant T. So according to this theta, this is our T first theta, and according to this theta, this will be our T sin theta. So finally we got to two components of the resultant. So in this direction, this will be our MA. Okay, opposite will be our MA. MA. And MZ is also downward. So T cos theta we wrote as a MZ and MA as a MA equal to T sin theta. Okay. First important point was action reaction pair law, which is the third law of motion, is not flowed by the pseudo force. Now second point, let's see. Second point. Second point, which is second point. First container. This is first container. Water is half water. One particle is over here. One particle is another container. Water is something like this. So over here, this is our F will be in this direction. Case number 1. Case number 2. Case number 3. Case number 3. This one particle, mz is a downward, net force will be our result. Mz will be downward, okay, mz will be downward. Acceleration is what? Direction of acceleration is in this direction. And over here, direction is in this. And over here, acceleration is 0. Acceleration of water is 0, okay. acceleration of water is 0. In that case, net external force will be downward. F net will be equal to mc. Okay, net external force will be downward. Reason is acceleration of water is 0. Okay, water is in a rest. Now, if acceleration of water is direction of acceleration is forward. In that case, we will take opposite. So net force will be this side, F net. Okay, F net. So component of F net will be this downward, which is known as mg, and this will be our ma. Clear? Ma. So net force will be in this direction. Mg is a downward. Over here. Just opposite of a acceleration will be our ma. So acceleration is backward. So ma will be forward. Clear? And mg will be downward. So net external force will be between them. This is our F net. So ma will be just opposite of acceleration, and mc will be always downward. So you will bring your F net. Okay. When water is in a rest, then acceleration is going to be 0. Total net force will be downward. When acceleration is forward, then our ma will be backward. And mc is always downward. So F net will be like this. If acceleration is backward, so ma will be forward. Okay, ma will be forward, and mc is always downward. So F net will come out like this. This a component of what component? These were three cases. Now we have some questions. First question is, to a sphere A and B are placed between two vertical walls as shown in figure. Figure is in front of you. This is one circle. Another circle is like this. This is another circle. B A. Okay, B. Question is asking. Show if B D free body diagram. Two a sphere A and B are placed between two vertical these two vertical walls as shown in the figure. So FBD free body diagram of one of A show. Okay, show FBD of A. FBD of B you have to show. Okay, so let's start with a circle. So FBD of A will be, so this is your circle. Am I correct? This is your circle. over here. Downward is what? Downward from here. Downward is mc. Am I correct? Downward is mc. And wall is pushing the A. Wall is pushing the A. So you would say, this is our N1, and the earth is pushing the A. Earth. So this is upward, N2. Who is pushing? The earth. Earth is pushing A circle. So these are forces: mg, gravitational force, normal reaction of earth, normal reaction of wall. Okay. And one more, which is A is also pushing B is also pushing. Am I correct? So you would say normal reaction of A according to B. This is our AB. Means B is pushing the A circle. This is our free body diagram of A circle. Now next, a small b. 1 mg. This is a fixed mg. Upward n1 upward n1. Okay, n1. Over here we have A, B. This normal reaction which is coming from A circle is pushing the B ball, and the ball reaction, normal reaction of the ball will be in this direction. Am I correct? N1 is from the earth. This is our FBD of B. But MC is not over here. Reason is this B ball is not on the surface. This is the reason. Okay, this is reason. You can take even you can take. So over here will MB, okay, MC. Now let's take next question. Next question is direct question. Friction is zero. Now in that case, draw free body diagram of the sphere of mass M placed between a vertical wall and horizontal ground as shown. All the surfaces are smooth. First of all, mg is a compulsory. Normal reaction of the vertical wall and normal reaction of earth. That's it. Vertical wall does not exert forces on a sphere. over here normal wall will be equal to 0, because reason is this normal reaction, it is not applying force on the wall. Okay, weight of the wall is completely on the earth, not with the wall. So over here just O is attached with vertical wall, nothing else. So force is 0, but force is 0. Force is 0. Now next question, force is 0. Force is 0. One end of a string, which passes over the pulley and connected to 10 kg mass at the other end of a string is pulled by 100 Newton force. Calculate the acceleration. Acceleration of 10 kg mass, and g is equal to 9.8 meter per second raised to power 2. Just understand first of all what is the question saying. Question saying one end of a string which passes over the pulley and connected to 10 kg mass at the other end of a string is pulled by 100. Look at over here. Mass of the block is 10 kg. Clear? So mg will be 10g. Value of z is 9.8. And pulley is pulling this object with 100 Newton. Try to understand. Mass of the object is 10 kg. Okay. Over the pulley and connected to other end of the string is pulled. This end, let's say it is connected by the pulley. This is connected by the pulley. So this end is pulling the object with 100 Newton. Clear? Or you can say tension is T is equal to 100. Calculate the acceleration of 10 kg. So acceleration would be how much? So by using Newton's law of motion, you can say net force will be equal to ma. Reason is here net force is not equal to 0. Reason is there is acceleration. Okay. So downward force is a 10g and upward force is a 100. You don't know direction of acceleration. That's why first you can start. You can write 100 upward minus 10c downward is equal to mass of the object is a 10. We don't know. So 100 minus 10c upon 10 will be equal to a. Just put value of z. You will get acceleration. So value of a, value of z is 9.8. So 100 minus 10 multiple 9.8 is equal to 10. So your acceleration is 0.2 meter per second raised to power. Just to simplify, acceleration will come the same magnitude, 0.2 meter per second. Try to understand. This block is going upward. Okay. So with this much acceleration, this block is going upward. Whose mass is 10 kg. 10 kg. And tension force is 100. Tension force is 100. Now next question. Next question is with figure. Let me draw figure. 10 kg block. Another block whose mass is 20 kg. Okay. There is a vertical wall. Clear. Angle is like this. Vertical 30 degree. Forces in this direction with the 50 Newton. Angle is at 30 degree. And 100 Newton force in forward direction. 100 Newton. You can see this is our question. Question is asking. Two blocks are kept in contact as shown in the figure. Find the forces exerted by surface, floor and wall. Okay, on blocks. Be contact force between two blocks. Contact force. This N. This N1, N2. So FVD. First of all, draw FVD of block. Okay, each block. One by one. First we have this is 10 kg. Try to understand. Downward will be 10 g. Upward will be N1 and over here. Try to see. This 20 kg block is pushing the 10 kg. So you can say we have N2, another N2. And 100 Newton force in this direction. Over here, all these are forces. Okay, this is gravitational force, this is normal force, this is our normal reaction force. So you can say 100 Newton is equal to N2. Can you say N1 is equal to 10 G? Yes. So N1 is equal to 10 G, which is equal to 100 Newton. And N2 is equal to 100 Newton. This is our answer. But for another body. Right, also. For another body. For another body which is like this, mg downward and n1, or you can say n3. Clear? This 10 kg block is pushing the 20 kg block, which is n2. This is our n2. N4 will be upward. N4 from earth. Angle by this force is a 30 degree, 15 Newton. Resultant is 30 Newton. So N2 will be equal to, you can say, N3. N2 will be equal to N3 plus N3 plus 50 sin 30 plus N3. Okay, N3 plus this much more force, which is a 15 sin 30. So over here 53 is N3 is how much? Value of L2 is given 100 Newton, 50 multiple 1 by 2 plus N3, 25. 100 minus 25, which is equal to N3. So N3 came out as a 75. N3. So over here we have 75 Newton. Value of N1 is 100 Newton, N2 is 100 Newton, and N3 is 75. You can calculate N4. You can calculate N4. Remember, N4 plus N4 plus 50 cos 30 is equal to mg, is equal to mg plus. So N4 is equal to 50 cos 30, which is equal to 20g. So 50 and cos 30 will be your root 3 by 200. 25 to the 50. So 55 root 3 plus 200. This is your N4. This is your N4. Okay.